battery provides electrical power to vehicle systems, or electrical power to start the vehicle, through a chemical reaction taking place between two dissimilar metals and acid located within the case of the battery. If the battery becomes successfully discharged so that these systems no longer operate, it may be possible to return it to a fully charged state by reversing the chemical reaction using an operating vehicle and a set of booster cables, or a battery charger. Battery chargers take electrical power from a wall outlet, adapt it to a point where it's compatible with the vehicle systems, and then by applying that power to the battery, it reverses the chemical reaction inside, and that returns the battery to a fully charged state. There are many, many different types of battery chargers, so it's incredibly important to be fully trained on the unit that you are using. I'm using an automatic, small, very compact battery charger, and it's referred to as automatic because you select a charge rate of 2 amps for slow charge or 10 amps for quick charge. And then the battery charger will shut off when the battery is at the fully charged state. Many industry battery chargers, however, use either a timer or you actually have to be present to physically shut the battery charger off when the battery reaches a fully charged state to prevent damage. Those chargers are often used because they have a higher charge rate and they're far quicker. But for the average person, a charger like this is going to work really, really well. Even though charger types vary, there are a few things you have to consider before hooking up a battery charger or a set of booster cables, and that's what I'm going to focus on now. The first thing you want to consider is what the acid level is like inside the battery. Now, some older batteries would have caps that screw off on the top of the battery, or they might have a window in the top or side so that you can see the acid level. In this case, I'm looking at a sealed, maintenance-free battery, so I have no real way of knowing how much acid is inside of it. So unfortunately, I just have to hook the charger up unless I can see a physical leak from the case of the battery that would indicate that it's empty. I have to trust that it's at the appropriate level. Secondly, you want to look at the plastic case of the battery itself. If the battery case is swollen in any way on the sides or end, that could indicate a few different things. First, it could indicate physical damage to the metal cells inside the battery. In that case, the battery needs to be replaced. Or it may indicate that the battery has frozen. Normally, the battery acid does not freeze, but as the battery discharges, that acid becomes closer and closer to water, and that gives it more and more potential to freeze and cause an issue. So if you see any kind of physical damage to the case itself, you're going to be replacing that battery, not recharging. A final safety consideration is that the chemical reactions taking place inside the battery are going to produce a highly explosive gas. And that gas is released through vents in the cap of the battery. That's part of the reason why if you ever see a vehicle with the battery mounted in the trunk or underneath one of the seats, there's going to be some kind of clear vent tube to the outside of the vehicle, and that allows that gas to escape instead of accumulating in the cabin or the trunk of the vehicle. In this case, our battery's under hood, so there's no vent tube, but there are vents on the battery, and we need to be aware that there could be a cloud of explosive gas near the top of this battery, so we want to be sure not to produce any sparks at all. That's part of the reason why they always encourage you to charge batteries in well-ventilated areas, allowing that gas to dissipate. Prior to hooking up our battery charger, we want to make sure that there's no potential for spark. And we're going to do that by ensuring our battery charger is unplugged. That way it's not pumping voltage up to the clamps on the end of the cable. Now, in the case of booster cables, you want to make sure that you're hooking up to the severely discharged battery first, because it has the greater potential for having a cloud of that gas around the top of the battery. So I'm going to take my clamps here from my battery charger, and you can see they're color-coded, red and black, and as well they're stamped positive and negative. And it's a simple matter, because they have no power applied to them, of hooking them up to the terminals on the battery. Once they're connected, I'm going to check my setting, and I'm on the 10 amp setting, and I can plug it in and allow it to operate until the battery is charged. When you're ready to disconnect the battery charger, you need to go through the same procedure of making sure there's no power to the battery charger prior to disconnecting. Because you've just spent however long creating a chemical reaction inside the battery, and you want to make sure that there's no gas hanging out near the top here that could explode. So we're going to start by unplugging our battery charger. And that means that now when I take my clamps off, there's no chance for there to be a spark to create a fire or explosion. So I can remove my clamps, and that battery should be ready to start the vehicle.